Okay, so we spent the last few segments of notes talking about dictionaries. And in the very, very last segment, we talked about how you really need to define new classes in order to handle more complex data structures in particular and deal with dictionaries that have more complex data structures. So now we're going to go into more detail about how we can expand use of these methods, make more user-defined methods to make use of more complex data structures. So a method, if you recall, are just an action that can be performed by some object. We just like in a lot of programming languages, such as R, in Python, you have methods and you have objects. So we've used a lot of methods now. We've even written a lot by this time. Um, so we have a lot of experience using methods on objects within Python. Methods are similar to functions, but they have a slightly different calling syntax. So um, for example, and sometimes we just think of these interchangeably in Python. We have an object A, and say we want to add gold to our account using this method, and the amount of gold we want to add is the value of 10, we would call this instead of this. Okay, so this looks more like a traditional function, and this is a method, and how we've been using them the whole course. This is just standard in Python. The first parameter is always self. Remember that keyword self. We don't include self when calling the method. Okay, when we call something like this method, add gold applied to A with value 10, self will refer in part or in particular to A. If the method takes, say, two parameters, it is defined to have three, essentially, the self and then the two, quote, real ones. Okay, so these are defined. How do we call it? Take a moment. We have a class, which is a thing applying to some object. So this defines kind of how it's structured, its attributes, and so on. And we've said T is an object of class thing. And E, D, E, and F are defined. Our function or method, there I go calling it a function. Our method, doIt, calls A, B, and C, and does something internally. We don't even worry about the ... here. The question is, how can we then take objects D, E, F, which are different than A, B, C, but would stand in for their rules? These are really just arguments, right? And how do we call it? Okay, well, let's go through a few rules, thinking back on the slide. First of all, we know, let's go back. We don't include self when calling a method. So which one of these does that rule out? B, right? We never call self. So B's out. Process of elimination here. All right. Methods are similar to functions, but they have a different calling syntax. This rather than this. So that leaves us with D and E here. These have that particular syntax used for methods within Python. So now the question is, how do we distinguish between these two? Well, this one includes a T as an argument, but we're already pointing to the object. So D. D is the right answer here. Okay, again, T is an object of class thing and D is defined. What's the proper way to call doIt? Okay, I hope everybody chose B here. Okay, so now we're going to make use of another special method within Python that's going to help us print things nicely. Okay, by default, print on some object, and print on some object gives you some memory address, which is not often a useful way to view or represent the object. How do we get things to instead print nicely is the question here. So the trick is to add this string method. Remember, this is another special method because it has the double underscore before and after, and it returns a string representation of that object. This is really useful. String concatenation, formatting can all be used with this special method here. We can also make use of the object attributes to build that string and make it more descriptive as well. So the information to include in the string depends on what kind of object you have. Okay, do you have an account, such as like a savings account and all the information? Do you have coordinate points? Or what is it? So we're going to add the following methods to our point class now. We're going to make use of this special method within Python that adds a, pardon me, that prints a string such as a traditional way we write out a coordinate pair, a coordinate point. So it gives those X and Y coordinates. It's going to include translate that moves the point at a certain distance X and a certain distance for Y. And then a distance that returns the distance between a point and some other point. Then we're also going to write a segment class for representing line segments, which will include translate and length methods associated with it. So I stopped. I was gonna make an additional set of slides, but I think I'm just gonna show you the program here. All right, so let's walk through this first of all and make sure we understand each part. Here we have a class definition. We're calling the class point. It's going to take an object and use a special way of assigning attributes and methods for an object that is of class point. Then we have to define methods, okay? So here's all, starting from here, all the way down to here, we've defined 4 methods. First, the method that is just our constructor. So this just creates the point itself. So remember that underscore, double underscore init is our constructor method. It's a special method reserved within Python so that we can define structure to these special class objects. Okay. Similarly, double underscore str is a special method specifically to return the way you want things to print. So here, notice it's just returning it with parentheses around it. So it looks like a traditional pair of points, coordinate points. Then we have here's just 2 functions, pretty simple, very simple functions. This function translate just moves the point by a certain distance horizontally, and by a certain distance vertically. You can change it. So there's a dx, a dy argument, and that's just the horizontal change, the vertical change. The kind of complement to that in a sense is the distance function or method, not function, but method. And what that does is it's going to take 2 points. You really just enter the point that is the other point, and as an argument, and then it finds the distance between those points, returns it as a Euclidean distance. So notice we're taking the horizontal, could not get that word out of my mouth. Horizontal difference squared, the vertical difference squared, returning that Euclidean distance between the 2 points in space. Okay, so if I run all of this now, I'm going to simply get the following. So let's see, I first declare a point, 2, 5, I print it. It's right there. Okay, easy enough. We've seen that before. But what's new is the printing, because we declared not only the attributes of that point using double score init, but also how it prints using double score str. All right, so it has that special way of being printed. Then we translate the points. So I want to add 3 to the horizontal distance, 2 to the vertical distance. So that's going to change my point 2.5 to 5.7. So add 3, add 2, easy enough. Then I printed it, so you can see it right there. All right. Last part, I apply to the P1 object. I want to find the distance between P1 and another point. So I just declared the point internally to the argument of the method. Okay. So I just picked a point. I chose 4, 4. I get the distance. That's the distance between 4, 4 and, well, now it's going to be 5, 7, because remember P1 is now 5, 7. All right, not the original 2, 5. I should have asked you that. What is it going to be? 2, 5 or 5, 7? It's going to be 5, 7. All right. All right, so make sure you understand that and make sure you ask me if you got any questions about that. I think we're going to pick back up here in class this week rather than doing any more online.